Hello, everyone. My name is Omer Gil, and welcome to Abusing CI/CD, Top Ways to Reach Production. Just before we make a formal introduction, let's see what the main goal for this talk is. So most of you probably work with CI/CD pipelines on a daily basis. Nearly any company that develops software has a pipeline to use to build, test, and deploy their code. Now, the usage of CI/CD is becoming more and more common as years go by. The best testament to that is this amazing statistic that we're seeing of the monthly executions in Jenkins, which is still the most widely used build system in the world. We can see that today there are nearly 58 million pipeline execution in Jenkins instances each month. It nearly doubles itself every 2 years, kind of the Moore's law of CI/CD. Now, attackers are aware of these statistics, and so today we will see how attackers are using your pipelines to reach production. So again, my name is Omer Gil. Hello, everyone. A bit about myself. I have a background of around 14 years in multiple security disciplines, both defensive and offensive, like hacking to web applications and cloud environments. Today, I lead research at Cider Security, where we are creating what we call the first AppSec OS. Our platform analyzes development technologies and frameworks in use across the CI/CD and secures both your CI/CD systems and pipelines, as well as the code and configuration flowing through the pipeline. Besides our product that we are highly focused on, we try to work with the InfoSec and dev communities to contribute in any way we can. One example for that is the top 10 CI/CD security risks initiative that we released a few weeks ago. We see that defenders lack knowledge and methodologies of how to protect their CI/CD ecosystem, and even more importantly, what risk they should protect against. So this project aims to assist us all in focusing on threats in this domain. This initiative is the result of an extensive research and analysis that we've done, and I really recommend you all reading it. And another example is the CI/CD GOAT, which is a deliberately vulnerable CI/CD environment with 10 different risks, challenges based on the top 10 risks to allow everyone the chance to practice on CI/CD hacks and defense. Now, what led to this talk today is the research that our team conducted in the past year or so, and on how attackers abuse CI/CD systems today. And I'm here to share some of these insights with all of you. So thanks for joining, and let's start. Let's start with a short background. So with the rise of DevOps and cloud computing, where everything is automated and deployed fast and easy using code, a new tech surface was introduced, which is reaching the organization's crown jewels, the production systems. This is where the money is at. This is where the data is at. So this is where attackers want to reach. Now, some of the most common attack vectors against these production environments could be first, breaching the perimeter, like exploiting a port open to the internet, or taking advantage of a SQL injection vulnerability, or any other vulnerability that you can take advantage of in order to step into the systems and then move laterally to try to achieve some sensitive data or access. Another example is abusing cloud misconfigurations, for example, like an S3 bucket open to the internet for any anonymous visitor, and exploiting workstations and endpoints to move laterally in the organization, get some strong access and permissions, and from there try to access the production systems. Now, as these attack vectors became more mature and common, security adjusted with methodologies and security systems, providing prevention and detection capabilities, and their actual positions with the purpose of dealing with these threats, like DevSecOps, cloud security engineers, and AppSec engineers. So as the attackers are having a hard time exploiting these vectors today, they are aware of how popular CI/CD is. And recently, especially during the past year, we see an evolving attack surface, which is abusing the software delivery process. This is around taking advantage of the connectivity and processes involved in shipping application and infrastructure code to production. Now you might think or ask yourself if your pipeline is secure. It's reasonable to think that it is. There is a set of typical security controls that exist to protect the software delivery process. You might identify at least most of them. Organizations have 2FA enforced on their source control management systems, or approvals are required before merging code to the main branch. You might restrict network access, or even try to do the impossible missions of reducing production permissions. But those controls aren't enough. Now, last year we witnessed again and again how attackers of all levels of sophistication were successful in running malicious code inside the software delivery process. One example was SolarWinds, where their CI was hacked in order to introduce malicious code to their executables used by their customers. CodeCove, where their infrastructure was hacked to introduce malicious code to the script used by thousands of customers that run this script in their pipelines. And this malicious script that was created by the attackers was used to steal environment variables that usually include secrets that were sent to the attackers' servers. And another example, which we see on a weekly basis, nearly on a weekly basis, is compromised NPM packages like the popular Koa and RC packages, usually again to execute malicious code in CI pipelines or in developers' workstations. So we see from all of these examples that hackers that are able to run malicious code inside an organization's CI are able to do the same things that the CI/CD can do, and that is get to production. And now you might think that your CI is internal, it's in the perimeter, behind the firewall, protected by a VPN, so it's not that easy to access. And hackers are like, oh yeah, challenge accepted. We know that the perimeter has long ago stopped being a security boundary, but more importantly, and this is also the focus of our talk today, is that attackers don't have to have access or permission to CI/CD pipelines to be able to run code inside CI/CD pipelines. So let's move on and talk about how hackers can hack your pipelines. What we'll see today are 4 different types of practical hacks. Just before we step into that and start covering them, let's start with where the attack flow starts from. So there is a basic pipeline. You can see a developer here with write permissions on the source control management system on a specific repository, which is linked with a Jenkins pipeline, which then deploys the code or infrastructure to, again, the crown jewel, to the production system. Now here comes the attacker. You can identify that it's the attacker because it's red and wears a hoodie. Now the attacker knows that it's not easy to directly access the production system, right? Because as I just said, there are many controls in place to prevent him from doing that. But he knows that the CI/CD, starting from the developer and the source control repository, this eventually leads through the CI/CD to production where he wants to reach. So maybe if he will get access to a developer's account and get write permissions on a repository linked with this pipeline, he might be able to go step by step until he reaches production. But it's not that easy to achieve, right? Because we see here just one developer with write permissions on this one repository. He might be able to phish this user or brute force their password, but it's not really straightforward to compromise a single developer. But as we know, this developer working on this repository is probably not working alone, but as part of a bigger team. So now we have 5 different engineers that the attacker can compromise each of them in order to get these write permissions that they need to access the repository. But still, compromising one of 5 engineers might be still a bit challenging. So lucky for the attacker, he knows that even though this team is working on this project, maintaining permissions in source control management systems is a huge mess. Probably not just this team has permissions on the repo, but many other people in the organizations. engineers from other teams, product managers, QA, whatever. Sometimes in a medium-sized organizations or even bigger, we see hundreds or even thousands of users that have access to most, if not all, repositories in the source control management system. And then the attacker just need to take control over one of them, and it could be different types of access. It could be getting access to their password or SSH keys or personal access token. Any type of access would be good in order to get these write permissions on a repository, and from there, the attacker can start and moving between the different stations in the CI/CD, which we're about to see now, in order to reach production. So now we'll cover these 4 attack vectors that I just mentioned that the attacker can use to reach production through this initial foothold in the repository. So the first attack out of 4 that we're going to cover is direct PPE, or direct poison pipeline execution. So the attacker has write permissions on the repository. And when he starts looking at the contents of this repository, you can see that it contains a Jenkins file, which is the configuration files that defines the pipeline triggered on the Jenkins instance. Now, there are branch protection rules configured in this repository, which is a highly common security and quality mechanism to prevent direct push to sensitive branches. So if the attacker would try to push malicious code directly to the main branch, this would fail. Same for trying to push malicious code in the Jenkins file in order to run malicious code in Jenkins, that would fail for the attacker. But what about pull requests? Now, pull requests also trigger pipelines, and pull requests are publicly unreviewed code that you also want to build, test, or scan for security issues in the pipeline. So this also looks like an interesting opportunity for the attacker. So the attacker decides to step into the Jenkins file code. Let's have a look at it. So this is the code of the Jenkins file. We can see that there are different stages here, like the build stage and the test stage. And inside the build stage that also run with the creation of pull requests, we see that AWS credentials are loaded into memory as environment variables, and then some make commands are run. What the attacker decides to do is to modify the Jenkins file with malicious code that when the AWS credentials are loaded into memory, he sends all of the environment variables to a remote server that he controls. So let's see what happens here. The attacker creates a pull request with the malicious Jenkins file that we just saw. Now, with the creation of the pull request, a pipeline on Jenkins is triggered. When the pipeline is triggered, it fetches all of the repository code as part of this pull request, which contains also the malicious Jenkins file. The thing is that this malicious Jenkins file will be the Jenkins file that now configures the commands for the pipeline to run. So now malicious code runs on Jenkins, which is now compromised. The credentials are sent to the server hosted by the attacker, which can now access and compromise production. Now, you might think that in order to execute a direct PPE attack, where the attacker directly modifies the configuration files that defines the pipeline, the attackers need to obtain access to a developer's account. And if the attacker already get access to a developer's account, there are many other attack vectors to execute, like moving laterally in the network and accessing production directly, etc. But I'd like to remind you the first slides in this talk, that today many efforts are being made to reduce the attack surface by other vectors to increase prevention and detection capabilities. And along with that, there are poor capabilities in CI/CD to detect and prevent these kind of threats. So I'd like to ask you, if a direct poison pipeline execution was executed in your environment, would you have the ability to know about it? The answer is probably no. Okay, so security and DevOps decided to protect against the modification of the CI configuration files when running unreviewed code that should prevent a scenario like direct PPE. This can be done in different ways, like fetching the Jenkins file from the main branch always, also in pull request, or storing it in a sensitive repository, which is more secure. And this will prevent a scenario of direct PPE. But does that actually mean that your environment is secure against PPE attacks in general? So the answer is, of course not, otherwise I wouldn't be asking. So let's move on to the second variant of PPE, which is indirect PPE, or indirect poison pipeline execution. So here the attacker starts from the same position. He has write permissions on the repository. But now the Jenkins file is protected. It can't be modified, and the attacker can't directly configure what the pipeline should run, what command it should run. But when the attacker has a look at the contents, the other contents of the repository, he sees that it also contains the make file. Let's see the protect the Jenkins file again. We can see that when the AWS credentials are loaded into memory, make build and make clean, these commands now run in the Jenkins pipeline. So let's have a look at the make file. We can see here the definitions of the different make functions in use in Jenkins. And we can see a build, plan, and clean. What the attacker can do is to modify one of these functions that are referenced by the Jenkins file, in this case, the build function, and replace it with his own malicious command. So let's see the attack flow now. The attacker creates a pull request. He doesn't change the Jenkins file now, but only the make file with the malicious command that we've just seen. Now the pipeline is triggered, fetching the code from this pull request. The Jenkins file defines what stages and steps should run and the commands in each step. So AWS credentials are loaded into memory, and then the make build command runs. But now the make build command contains the malicious commands inserted by the attacker. So again, malicious code which has access to these AWS credentials are sent to the credentials are sent to the attacker server, which can now compromise, access and compromise the production environment, AWS in this case. So this is indirect poison pipeline execution. Rather than poisoning the pipeline by inserting malicious commands directly into the pipeline definition file, in indirect PPE, an attacker injects malicious code into files referenced by the configuration file. Okay, so moving on to the third and last variant of PPE, which is public poison pipeline execution, or in short, 3PE, the 3PE attack. Now here the attacker starts from a different position than we've just seen. The attacker didn't obtain write permissions on the repo. Instead, in this case, there's a public repository linked with a Jenkins pipeline. Now public repositories, as you know, like in open source projects, allow any user to contribute, usually by creating pull requests, suggesting changes to the code. These projects can be linked to a CI, just like internal projects, to automatically test it or build it, for example. Now, to execute a PPE attack, whether direct or indirect, the attacker can fork the repository, and then he can modify the Jenkins file to contain malicious commands similar to the steps in direct PPE. Now, if the pipeline of a public repository is configured to execute the pipeline with the creation of pull requests, this pipeline in Jenkins will be triggered, fetching the code from the fork, sorry, in this case. And now this Jenkins file, which was modified by the attacker, again, like in standard direct PPE, it will run the malicious code created by the attacker in Jenkins. It will send the credentials to the attacker, which can now access the production environment. So if the pipeline of a public repository runs unreviewed code suggested by practically anonymous users, it is susceptible to a public PPE attack, depending on how secure the configuration of the CI is. Now today, there are built-in controls in SCMs to protect against public PPE, but still, it can be configured insecurely and allow attackers to take advantage of this scenario of 3PE. So just before we move on to the fourth and last attack vector that we're going to cover today, which is not PPE, but something else, let's have a short summary of comparing PPE to the a more traditional Active Directory or cloud-based attack techniques to gain for the attackers to gain a strong foothold in the organization. So in terms of difficulty of exploitation, so traditional techniques sometimes require more advanced skill and technical expertise by the attacker, these are crafts that sometimes take years to learn. In PPE, you just need to create one pull request. In terms of likelihood of exploitability, how likely an environment is to be exploitable. So in traditional techniques, they are well known. And there are various protections in place, as we already discussed. And in PPE, nearly any environment we saw by today was susceptible to this attack. In terms of likelihood of detection, so again, traditional techniques have various detections, alerts, people hunting for them. And in PPE, if you're an attacker issuing a malicious pull request, you're unlikely to be caught. And in terms of impact, in both cases, the impact is high. In both of them, you can reach sensitive assets like production environments. So the choice for what to do if you gain the permissions or compromise the workstation of an engineer is pretty obvious. We can see that today for attackers, PPE might be an easier attack vector to execute without being detected so easily, comparing to the more traditional techniques which are still widely used by attackers, but are more known for defenders as well. So moving on to our last attack vector for today, which is not PPE again, which we're going to see how we can bypass required pull request reviews in GitHub. So here we have an environment where GitHub specifically is the SCM, and there is a repo linked with Jenkins. Now also, this environment is a bit different than what we've just seen in PPE, as the CI pipeline is only triggered when code is pushed to the main branch and not on creation of pull requests. Now, branch protection rules are configured here as well. So if the attacker would try to attempt to push malicious code to the main branch, whether malicious applications code or infrastructure code, or an attempt to execute a PPE attack, it would fail. So the possibilities for the attacker are very limited. The users can't approve pull requests they create, as that would fail this entire security and quality mechanisms of approvals of pull requests. The attacker can be naive and create a pull request with the hope that some other developers would approve their malicious PR. But I assume that if they would try to fool a developer to approve malicious code, it would probably fail. So the attackers can only create a pull request with their malicious code that they can't merge it to the main branch, or can they? Let's see. So this is where GitHub Actions steps in. But why am I talking about GitHub CI solution, which is not even in use in this specific organization? So there is something interesting about GitHub organization that you should know about. Any GitHub organization has GitHub Actions installed and turned on by default. Any user that has write permissions on the repo can create a workflow file. This is how actions pipelines are defined, like same as the Jenkins file. And these workflows will immediately be executed. Sounds like an interesting avenue for the attacker, but even though GitHub Actions won't lead to directly to production in this environment, because it doesn't store any secret or have direct access to any sensitive asset. But still, something interesting that the attacker can try and use for their purposes. So what can the attacker do? The attacker can create the following workflow in the repository as part of a pull request that he creates. We can see on line number 3 that the workflow is triggered on the creation of pull requests. Also, the developer, you can see it in lines number 5 and 6. The developer can define for which workflow in GitHub Actions if it would run with read or write permissions against the repository. Now, it shouldn't be a big deal, right? Because the attacker already has write permissions on the repo. But another thing that you should know about GitHub Actions is that the workflow which runs, it runs with the GitHub Actions bot user. and not with the identity of the developers that triggered the pipeline, that triggered the workflow. So the bot user counts as another developer from the user that triggered the pipeline. At the bottom of the workflow, you can see that the code that runs in the workflow. You can see that it's a simple API request towards GitHub's API, directing to approve the pull request that triggered this workflow. So let's compile this whole attack flow together and see what the attacker can do. So the attacker creates a pull request with malicious code that he wants to eventually introduce to production. It could be, again, malicious application code, malicious infrastructure, or even a direct PPE attack, like modifying the Jenkins file that is also in this repository. Along with this malicious code, the attacker creates the malicious workflow for GitHub Actions. Now the attacker creates this pull request, and then with the creation of this pull request, the workflow is triggered. It has write permissions against the repository, and it approves the PR with the actions bot, the GitHub Actions bot user. So now the attacker got the approval that he needed, and is not blocked from merging the code into the main branch. And now he can successfully merge the code in the main branch in the repository. Now, with this merge of the pull request, this merge actually triggers the actual pipeline used in this environment, the Jenkins pipeline, that sends the production credentials to the attacker, which can now access AWS. Now, I reported this vulnerability to GitHub a few months ago through their bug bounty program. They acknowledged it and released a fix that allows you to restrict actions reviews from being counted towards approval. You should know that this security setting is not set securely by default in existing organizations, just in new ones. So if your GitHub organization was created more than around 6 months ago, I recommend having a look at your organization settings and prevent GitHub Actions from being counted towards pull request approvals. So we've covered 4 attack scenarios. Let's have a short summary of what we talked about today. So we've talked about 3 variants of PPE, poison pipeline execution attack, which is, again, a method used by attackers to run code in the CI without having direct access to the CI, and from there, move laterally towards sensitive systems. We talked about direct PPE, where the attackers alter the CI configuration files directly. Indirect PPE, where the attackers alter another file used by the CI configuration file. And we talked about public PPE, or 3PE, where PPE is exploited through public repositories. And besides that, we saw a method in GitHub to bypass require pull request reviews using GitHub Actions, even if this CI solution is not in use or was never used in your organizations, in your GitHub organization. So to summarize, pipeline jobs are practically code execution as a service. This is how you see it, but this is also how attackers see it. And I would like to end this talk with leaving you with just one question to ask yourself. How far can an attacker with your permissions go? So with the famous words of Hattori Hanzo, I'd like to thank you for being here today. I really appreciate it. You're welcome to the Cider security blog. Very interesting materials that we keep writing on CI/CD security, like a thorough post on PPE, poison pipeline execution, this GitHub vulnerability that we just covered, the top 10 CI/CD security risks initiative, which I highly recommend you to read, the CI/CD GOAT project, the deliberately vulnerable CI/CD environment in case you want to practice on CI/CD attacks, and much, much more. Thank you, everyone, and I'm available to any questions you may have.